Unit 8 is called Related Rates and Function Analysis. And so this is a short unit, but the problems are kind of lengthy. They're all word problems, and a related rate, I keep wanting to say a related rate is seeing how different things are changing in shapes. So this kind of involves some geometry. It's going to involve some implicit differentiation we've been doing. All of those together plus word problems where you have to figure out the formulas. And so exactly what is a related rate? They're problems that involve two or sometimes more variables that change at the same time, possibly at different rates. So that would be like a ball, which is a sphere, blowing up with air. So its volume would be changing as its radius is changing because it's getting bigger, right? If we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing. So these are kind of like a puzzle. We've got a rectangle, has a length of 12 inches and a width of 1 inch. So 12 by 1. Whose sides are changing. So for whatever reason, I don't know what kind of rectangle would change, but it's the length is going to decrease by 3 inches per second and the width is growing at 2 inches per second. What is the rate of change of the perimeter? So what I would first do is figure out what are they asking me to find. When they say the rate of change, that's going to be a d something over dt. Everything in these problems is changing over time. So I'm going to put dp for perimeter. How is the perimeter changing according to time? That's what we need to know. Okay, so what else do we know? The length is 12. The width is 1. We may or may not need that. The length is decreasing by a rate, so many inches per second. So what that means is that I'm going to write dl. So the length is changing with respect to time. And since it's decreasing, I'm going to do -3. And sometimes I like to put the label in there inches per second because then it matches. The length is going to be in inches and the time is going to be in seconds. And the width, so I'm going to put dw to dt, is growing. So that would mean it's increasing by 2 inches per second. Okay, so I got to figure out how to find this. Well, I'm going to need to come up with a formula that connects all these things. And obviously that's going to be perimeter. The perimeter of a rectangle is just adding up the sides, or it's taking 2 times the width plus 2 times the length. And so now what I need to do is take the derivative of this whole thing implicitly with respect to time. Okay, so every variable is going to get a d whatever to time because I don't have any t's in it. Think of like when we did it according to x, every y got a y prime or a dy to dx. So the perimeter is going to change with respect to time, so we'll get dp over dt. 2w is not a product rule. So it would normally just be a 2, but since we're taking the derivative of w with respect to time, we get a 2 dw to dt, and then plus a 2 dl to dt. How's the length changing to time? So all of this work now pays off because I have things I'm just plugging in. They want me to find this, so I know I'm not going to have a number here. dw to dt I've already put here is 2, so I'll have 2 times 2 plus 2 times dl to dt, which is -3. And that's 4 minus 6, which would be -2. And what that would be is inches per second. So that's how the perimeter is changing according to time. Every second it's losing 2 inches of its perimeter. So kind of cool. We didn't even need these because that was nowhere my formula to plug in. I only needed the rates of change. We'll get to ones that are harder where you might need those constants. All right, let's try another one. A rectangle has a length of 12, a width of 9, whose sides are changing. The length is increasing by 7 inches per second, width is shrinking at 4 inches per second. What is the rate of change of the area? So the area is going to connect the length and the width this time. Okay, so again, my constants, let's just say that my length, 12, width 9. I may or may not need that. I know that I'm trying to find the area, and I know that that's going to be length times width of a rectangle, and they're wanting me to find that change of area according to time. So that's my end goal. Then I'm going to say that the length is increasing. So the length is changing according to time by 7 inches per second. The width, so I'll put dw to dt, is shrinking, so -4 inches per second. Then I need to take my area formula and take the derivative of it with respect to time. So that gets dA over dt. That was the area changing according to time, which is what I'm going to want to find. This is a product rule. So I'm going to keep L. I'm going to take the derivative of W, which would normally be 1, but with respect to time, it's going to be dW over dt. Plus, I'm going to keep W, take the derivative of L, which would normally be 1, but it's with respect to time, so times dL over dt. So again, we're making a substitution because we have a number for this change and this change. Ooh, I do also need the L and the W this time. So dA to dt gonna equal my L, which is 12, times -4, plus my W, and then dL to dt, which is 7. That'd be -48 plus 63, which is what? 15, right? Yeah. Okay, so my area is changing with respect to time of 15 squared inches per second. And it's growing. And that's my answer.